Hey, Jeaner, let's do number 4, which is actually a pretty tricky question if I'm doing it correctly. I was never really good at this ion stuff, so you might need to double check me on this work. Okay, so question 4 says that we're trying to calculate the volume of 0.46 moles of calcium chloride, and we're trying to calculate the volume of this. So let's say volume, and it has to be diluted with water to prepare a. So we're trying to find the volume of water that we're mixing this with to prepare a 145 milliliter 0.432 molar chloride solution. So basically what's going on is we have calcium chloride, we're adding water, and it's breaking up into its ions because that's what they do when you mix it with water. And so kind of a good thing to start with would be just to write the dissociation. So that means that like CaCl2, which is the calcium that we're starting off with, and once you add water, it dissociates to Ca 2 plus. If you look in the periodic table, it's a 2 plus, and then Cl, since there's 2 on this side, you have to balance it, so there's going to be a coefficient 2. If you look in the periodic table, it's a 1 plus. Okay, so that's the dissociation equation. And the last thing you have to know is a simple equation. I don't know if there's a formal name for it, but it's basically saying that the molarity of a solution times the volume of a solution is equal to the molarity of a solution times the volume of another solution. And so basically I'm going to be using this information for this MV and then this information for this MV. And so what we have is 0.46 times some volume that I don't know times 0.432 times the volume of that thing, which is 145. And one thing you have to watch out for whenever using this MV equals MV equation is units. Just you could use any units you want as long as they're the same consistently on both sides. So what I'm saying is if this is in moles and this is in milliliters, then this better be in moles and this better be in milliliters. So basically when I'm solving for this V, I'm getting it in milliliters simply because this is also in milliliters. Okay, so let's see, what is this? Whenever we solve for V now, we get that V is equal to 136.17 milliliters. And so now this is where the really confusing part comes in. And this part I'm not 100% sure on, but I think because they made a pretty big deal about this being a chloride ion solution, it's saying with respect to this chloride ion. And so like the opposite thing that they could have asked was for the calcium ion solution, in which case that this 136.17 would be the right answer because we're calculating basically for 1 mole. But because they're asking about this chloride ion solution, I'm pretty sure that they're actually asking for 136.17 divided by 2. That's because of this 2 right here, and because this is calculating, this whole volume is calculating assuming 1 mole, and this is 2 moles. Whenever you do this equation, you actually have to divide it by 2. So whenever you divide 136.17 divided by 2, what we get is 68.085. So I'm pretty sure that this is the volume that they're looking for, but again, I'm not 100% sure, but I am pretty confident it's going to be either 136.17 or 68.085. My best guess it's going to be 68.085. Again, because of this whole rule right here, this equation is what we're solving for. And whenever I'm calculating a volume, it's calculating the volume for this whole equation. So if they're asking for the volume of calcium, because there's only a imaginary 1 coefficient right here, it would be this 136.17, but because there's 2 chlorines coming in, we're actually having to calculate for 2 instead of 1, and so we divide by 2 to get 68.085. Alright, good luck on this question. This one's confusing.